Hello and welcome back. I'm Data Science Dom, and today we will have a look at the different stages of classification as a machine learning task. So let's dig right into this. So let's get started. Last time we had a look at the different components or tasks in machine learning. To keep in mind, we are currently in the supervised learning stage, which we see on the left hand, where we train the model with labeled data. And furthermore, we are currently thinking about classification or regression stage as those tasks or different stages I want to mention today are necessary for both stages. So with that in mind, we go to the next slide where we see what was classification. It's also from the last video where we have a look at labeled data again. Like we have features like age and height, and we have a class which we want to predict. The class is the label in the end. So we know the truth, want to give it to the algorithm, and somehow the algorithm should predict with different features, could be more than only those two, that the class is either a young adult or an adult itself. This is the key concept of classification. This is where we stopped last time. And this time we go into the specific stages. The first stage, as already mentioned by name, is the training stage. The training stage, we have a training set with feature vectors. Feature vectors are called, imagine it like the rows in a data set. Like we had on the previous slide, we had two rows, a young adult and an adult itself. So the features are the columns and the rows are the feature vectors in the end. And the label is the idea which we want to predict. So that's what we see on the arrow on the left hand side. We see we have F1, F2 until Fn and the label itself. F1, F2 are the features and the label is the young adult or class category in the end. So what we now have is that with the training set, we have the known labels. We know that that in this training set we either have a square or a circle, for example. And we tell the algorithm, okay, it's a square or a circle. Then the classifier in the middle gets those data points in the end and extracts some knowledge beneath. And we have some knowledge base. This depends absolutely on the algorithm we will use in the end, but we can imagine it like, for example, a regression. For example, if we have the regression, we see we have data points. And in the middle, we have a decision function. The decision function separates those data points. Some better, some worse. But if we imagine it in a two-dimensional space, where we have like the age and the height feature, we could try to separate it with such a decision function. And this is, in some cases, the idea what knowledge is extracted. Just imagine it like this. And this knowledge will be, like this regression will be adjusted to the training set. And later on, the classifier processes data and learns the patterns from this. And in the next step, the testing step, we go back to this knowledge. This knowledge was learned on the training set. And now we have a test set. The test set, we want to check if our classifier performs actually good. And to check this, we give it unlabeled data. So we give it feature 1, feature 2. So we need to give it exact same features as we had in the training set. Sometimes it's more than only those two, as I already mentioned. And in this step, we see, okay, he can predict circles and he can predict squares. And we see, oh, there's also misclassification. And the most important part is in the testing stage, we know the labels. So we split it from the original data set, but we don't give the classifier the labels at hand. So the classifier predicts the label, either is it an adult or a young adult, but we don't have the ground truth given to the classifier. We know it in the end for us to can evaluate is the algorithm good, because the most important part, as already mentioned, is we want to generalize. So if we are in a training stage and the model is perfect in the training stage and can divide every sample into the right category, it's not a good sign for us to know, okay, is the algorithm good or not? the algorithm needs to be good on the test set with the unlabeled data, because the algorithm does not know at this stage what is correct and what is not correct. It just goes onto the knowledge base it extracted previously. So in this case, it is really important to measure the performance of the algorithm here. How we measure this performance in the end, we will analyze later on. But just imagine here we have no labels into the classifier, but we compare it with the actual labels. This is the second stage. So remember, first stage, we have labeled data. We know, the classifier extracts the knowledge. Second step, we have labels for us, but not for the classifier, and it uses this knowledge. And now the third stage, which is in productive environment. So if we have like projects here and coding something, we won't go to the third stage, but this is the usual operation stage. This is when you deploy the algorithm. This is when it gets into use. This is the hopefully the goal of your algorithm in the end. So we have unseen data, as well as in the testing stage. We have no labels, we have unseen data, and the classifier predicts on extracted knowledge. And now there's only one difference to the previous slide. Ourselves does not know what is a misclassification, because we don't know the labels at the end. So imagine, if I have a data set with, as we've seen, with young adults and adults, and I can classify them on the training stage based on the labels we have, and in the testing stage, I can evaluate them. In the operation stage, we want to deploy the algorithm, and somebody wants to enter his or her data in the end, and will get a prediction therefore. The person wants to know if the person is a young adult or an adult itself. Seems pretty trivial, but in the end, this is the stage where we don't know the ground truth. This is where the prediction gets done in the end. This is the third stage, where the algorithm should be deployed and will be used in a productive environment. And in this case, we can't know the labels beforehand. To sum this up, first stage, we have labels, algorithm trains, gets knowledge. Second stage, we use this knowledge to predict on unseen data, but we know the labels yet. And third stage, we don't know the labels, and it's exactly like the second stage, but we will never know if there's any misclassification. So that's why it's so important to evaluate the algorithm in the testing stage. And how we do this, we will see in further videos. Thank you so much for listening. Don't forget to subscribe to the channel, like the video, and follow for more simple explanations.